Okay, thank you very much, dear students. Welcome to my channel, Pharmaceutic Mentor. And by Pharmaceutics Mentor, today we have to discuss very important topic of pharmacokinetic profiles of non-compartmental parameters. In this video, we will learn how to calculate clearance, how to calculate VD, how to calculate dose of such drugs who follows non-compartmental approaches. Before starting this, I want to explain NCA, and we are discussing the exercise number 13 of our book, where we have given you the data for calculation of all these. These all parameters are very much important for the calculation of even any type of the drug or therapeutic value. If we want to perform the therapeutic drug monitoring TDM, then we need these parameters. What is the clearance of the drug? What would be the volume distribution of drug? And how can we decide the dose of the drug? In case of NCA and non-compartmental analysis, we can calculate by clearance by using the simple formula of area under the curve, which is already explained in the previous videos. And in case of clearance, we have the formula of dose over K into AUC, 0 to infinity. And in case of VD, we have dose over Cp. And in case of dose, we can calculate this with KVD into AUC 0 to infinity. And these are the basic terminologies which we have to calculate. I will explain you the basic concept of the clearance today, how to calculate the clearance of the drug. And first of all, we will define the clearance. Clearance is actually a volume of plasma or body fluid which is getting free from the drug irreversibly. If we are discussing the amount of plasma in units of the liter or ml, and it is getting cleared from the drug in unit time per hour per minute, then we can say clearance is the units of the volume and time. And for example, if a drug have the clearance 4 ml per minute, this shows 4 ml of the plasma is now getting free from the drug in a minute and irreversibly. So for the sake of clearance, we have to make the units of the ml per minute, liter per hour. These are both common units which we are using for the sake of clearance. Okay, in case of clearance, we have to calculate the area under the curve. In non-compartment analysis, I have already given you the concept of the area under the curve in my previous video, where we calculate the area under the curve by segment the two areas, 0 to infinity and AUC 0 to t plus AUC 0 t to infinity. Okay, now today we will use the exercise number 13, and by taking the data of exercise number 13, we will calculate these terms of the clearance. Okay, our data is, we have the two profile of the data. One is time and other is the concentration. Time are in the units of R, concentration are in the units of milligram per ml. Okay. In the form of data, we have at 0 time, then 0.5 R, then 1, 2, 4, 6, 8, 1, 2, 4, 6, 8, and so on 10, and then infinity. Okay, concentrations are 4.05, 7.6, 4.05, 7.6, then 13.7, 27.4, 18.7, and 8.53. This is the basic profile of the data. Now our target is to calculate the clearance of the drug, and for the sake of clearance, we have to calculate first AUC, 0 to infinity. I will write it in very simple manner because AUC videos are already available on my channel, and we will calculate the AUC by taking the average of this and difference of the time. For example, we have 11 number here and divided with the 0.5, so our answer is 6. And next we have answer is 6. We have the average of 10 and then multiply by 1, it's a 10. Then we have 30, 40, and then we have 18 plus 27, almost 45. So these are our area under the curve from 0 to t, and then we will calculate area under the curve from t to infinity. T to infinity, that would be Cpn over K. We have already known about this because for the sake of K, we will draw the graph of Cp and time, calculate the K, ln C2 minus ln C1 over T2 minus T1. Okay, after getting the value of K, for example, we have the value of K is minus 0.1. So our last observed concentration is 8.53. We will divide this 8.53 with the zero point 0.1, and then we can get the answer is, say we have the decimal of this and decimal of this, so our answer is 80.53. And this difference is, now we will add the cumulative of this 45, 40, 85, 10, 95, 10, 6, and 105 was our this. When we add both, we will get the 185 point something, our area under the curve 0 to infinity. Our first segment is now calculated to calculate the VD or clearance. Okay, we will see the data. What is the dose of the data? For example, we assume that dose of the data is 30 milligram. So we will divide this 30 with the 185 and multiply with the 0.1 K. We have the clearance. So clearance is the basically ratio of these both concepts of the divide dose with the K into AUC. And our next segment is to calculate the VD. VD is the basically concept for dose over Cp. So by taking this graph, we will extrapolate it, and this point would be equal to the Cp naught. For example, if this value is 100, then we will divide this 30 with the 100, and we will get the VD in liters. Volume distribution is the basic type in which we assume that the hypothetical volume in which drug getting to be dissolved is called volume of distribution. So volume distribution, VD, and clearance will give us the concept of the and other parameters which we required. For example, if you want to calculate the dose, then we will multiply this VD with the CP naught, because in this term we will have the X naught is equal to VD into CP. And if we calculate from here dose over CP, from AUC we have the formula for clearance dose. We can calculate by using the AUC, rate constant K, and then the half life, then our volume distribution. Similarly, we can also calculate the half life by taking the K, and our simple formula is, for the sake of half life, we have K is equal to 0.693 over T half, and so T half is equal to 0.693 over K. This is all about the pharmacokinetic parameters of by using the non-compartment analysis. When you complete this exercise, you will get a table. In this table, you will have to calculate area under the curve from 0 to infinity. Then you have to calculate the drug half-life, volume distribution, drug clearance, and initial dose, which would be X naught. I hope you understand this basic criteria of the non-compartment analysis to check the pharmacokinetic behaviors of drug which is given by IV. Even it's a oral data, so like to be an oral calculations. Thank you very much for watching. Hope you understand this basic concept.